Hey everyone, welcome to Venus Neuron, your go-to resource for medical school success. Now in this video, we're going to talk about different types of primary bond, how to define whether a molecule is polar or nonpolar, about dipole moment, about VSEPR theory, and molecular geometry, and all the related stuff to it. Okay, now if you want to know about ionization energy, electronegativity, and electron affinity, go watch the first video about periodic table and the trends in it. Okay, now let's get started. What are primary bonds? Primary bonds or strong bonds are the main types of chemical bonds that hold atoms together in molecules and solids. These bonds involve the sharing or transfers of electrons between atoms and are much stronger than secondary or intermolecular forces like hydrogen bonds or van der Waals forces. We're going to cover them in the next video. Don't forget to watch that. Now, let me give you a tip. When we say intramolecular, it means within a molecule, and when we say intermolecular, it's between molecules. Okay? Now, what are different types of primary bonds? We have covalent bond, ionic bond, and metallic bond. Okay? So, what's a covalent bond? A covalent bond is a type of chemical bond when two atoms share electrons to achieve a stable electron configuration, usually a full outer shell. Okay? So atoms will covalently bond with other atoms in order to gain more stability. That's the goal. So when we say full electron shell, it's called the octet rule. Covalent bond occurs between two nonmetals, such as hydrogen, oxygen, carbon, nitrogen, chlorine, etc. For example, we have water or H2O, we have oxygen gas or O2, and methane or CH4. So how do we know if a bond is covalent? To determine if a bond is covalent, let's check some points. We can check type of elements involved. Covalent bonds are between two nonmetals, such as water, carbon dioxide, and methane, and ionic bonds are between a metal and a nonmetal, such as sodium chloride, magnesium oxide, and so on. We can also check electronegativity difference. If the difference is less than 1.7, it's a covalent bond, and if it's greater than 1.7, it's an ionic bond. Also, there's the concept of polarity. So, if we have a polar covalent bond or a nonpolar covalent bond. So, what is polarity? Polarity refers to the distribution of electric charge within a molecule, which determines the molecule's overall electrical properties. A molecule is polar if it has an uneven distribution of charges, meaning there is a partial positive charge on one side and a partial negative charge on the other. If the charges are evenly distributed, the molecule is nonpolar. Polarity is essential because it affects a molecule's interactions with other molecules. Its physical properties like boiling point, melting point, and solubility, and its chemical reactivity. So, how do we determine if a covalent bond is polar or nonpolar? First thing you can check is electronegativity difference. In a nonpolar covalent bond, it's between 0 to zero point 0.4, so equal or nearly equal sharing of electrons. Okay, so a nonpolar covalent bond is created when atoms share their electrons equally. When two atoms have similar or same electron affinity and they will have same electronegativity, it happens. And about polar covalent bonds, the difference in electronegativity is 0.5 to 1.7. So there is unequal sharing, creating partial charges. So basically, it's created when the shared electrons between atoms are not equally shared. When an atom has a higher electronegativity, that's when it happens. The atom with higher electronegativity is stronger, so electrons will be closer to that atom. Okay? Another way to determine if a covalent bond is polar or nonpolar is molecular symmetry. So, in nonpolar molecule, if the bond Dipoles cancel out due to symmetry, that will be nonpolar, such as in carbon dioxide or methane. But in a polar molecule, if the bond dipoles do not cancel out, making one side slightly negative and the other positive, that's for a polar molecule. We have it, for example, in water. Now, a quick trick to identify bond types. If you have a metal and a nonmetal, that's going to be an ionic bond. I'm going to explain what it is in a few minutes. And if we have two nonmetals together, so nonmetal and nonmetal, it's a covalent bond. If we have two nonmetals, if it's a small or no electronegativity difference, it's a nonpolar covalent bond, and if it's moderate electronegativity difference, that's a polar covalent bond. Sounds funny when I say it, right? Now, let's talk about understanding dipole moments and VSEPR shapes. To determine if a molecule, not just a bond, is polar or nonpolar, we consider two main factors. The first one is bond dipole moments, which is from electronegativity differences, and the second one is molecular geometry from VSEPR theory. Now about bond dipole moments. A dipole moment occurs when electrons are unequally shared in a bond, making one side partially negative and the other partially positive. In nonpolar bonds, atoms share electrons equally, such as in oxygen, nitrogen, or methane gases. And in polar bonds, one atom pulls electrons more strongly, which has basically higher electronegativity, creating partial charges, such as in HCl or H2O. Okay, now about molecular geometry and VSEPR theory. Even if a molecule has polar bonds, it might be nonpolar overall if the shape is symmetrical, which basically cancels out dipoles. We have some common shapes and polarity. If the molecular shape is linear, so basically 180 degrees, such as in carbon dioxide, the bond polarity will be polar, but the molecular polarity will be nonpolar because dipoles cancel out each other. If the shape of the molecule is bent, which the degree is 104.5 degrees, such as water, both bond and molecule are polar because dipoles do not cancel each other. If we have a trigonal planar shape or 120 degrees, such as BF3, the bond polarity is still polar, but molecule is nonpolar. Symmetry cancels out dipoles. If we have a trigonal pyramidal shape with 107 degrees, such as in NH3, the bond is polar and the molecule is polar too, because lone pair causes asymmetry. And lastly, we have tetrahedral with 109.5 degrees, such as in CH4 or CF4, in which the bond is polar but the molecule is nonpolar because it's so symmetrical. So key rule is that in symmetrical shapes, such as a linear shape, a trigonal planar shape, or in a tetrahedral, we have a nonpolar molecule if outer atoms are the same. And in asymmetrical shapes, such as band or trigonal pyramidal, we have a polar molecule because dipoles do not cancel each other. So far, you've been learning about VSEPR theory, but you had no idea. So, what does VSEPR theory say? VSEPR theory, we say it this way, but there's no E between we and S, okay? So, don't mistake it, that's just how it's pronounced. It stands for valence shell electron pair repulsion theory, and it is used to predict the shapes or geometry of molecules based on the idea that electron pairs around an atom will arrange themselves in such a way as to minimize electron-electron repulsion. In other words, electron pairs, whether bonded or lone pairs, try to get as far apart as possible to reduce repulsion between them, leading to specific molecular shapes. The key concepts of this theory are first, electron pairs repel each other. Electrons being negatively charged repel each other according to VSEPR theory. The electron pairs around the central atom, whether they are bonding pairs or lone pairs, will arrange themselves in positions that minimize the repulsion. The other key concept is electron groups, which include both bonding pairs, shared electrons between the atoms, and lone pairs, unshared electrons on an atom. Each of these groups occupies space around the central atom. And lastly, we have molecular geometry. The geometry or shape of the molecule depends on how the electron groups arrange themselves to minimize repulsion. Do you want to know the steps how to predict molecular shape using this theory? Cool. So the first one is to determine the Lewis structure of the molecule to identify the number of electron groups around the central atom. Then you count the electron groups around the central atom, both bonding and lone pairs. And lastly, determine the geometry based on the number of electron groups. The more groups there are, the more space the molecule needs to minimize repulsion. If we have two electron groups, we have a linear geometry. If we have three electron groups, it's going to be trigonal planar geometry. If we have four, it's going to be tetrahedral. If we have five, it's going to be trigonal bipyramidal. And if we have six electron groups, it's going to be octahedral geometry, which is shaped like an octahedral, and the bond angle is 90 degrees, and we have it in sulfur hexafluoride, or SF6. Okay, that's enough with all of that. Let's move back to the primary bonds and talk about ionic bond. So, an ionic bond is a type of a chemical bond that forms between two atoms or ions with opposite charges. It occurs when one atom transfers electrons to another, leading to the formation of positively charged ions, or called cations, and negatively charged ions, or anions. The oppositely charged ions are then attracted to each other, holding the two atoms together in an ionic bond. So basically, that's how you say it. It is a primary bond formed between cations, mostly metal, and anions, mostly nonmetals. And due to this bond, the atoms gain or lose electrons. Okay? A key characteristic of ionic bond, except the formation of ions and strong electrostatic force, is crystal lattice structure. What is that? Ionic compounds often form lattice structures, which are 3D repeating patterns of ions in which each positive ion is surrounded by negative ions and vice versa. Ionic compounds have high melting and boiling points. They are soluble in water, they have electrical conductivity, and they are brittle. So, ionic compounds are often brittle because if the crystal lattice is disturbed, for example, by a hard blow, alike charges may be brought next to each other, causing repulsion and breaking the lattice. Examples of ionic bond, for example, we have sodium chloride, or NaCl. Sodium is a metal with one electron in its outermost shell, and it will lose this electron to become a positively charged ion. Chlorine, on the other hand, is a nonmetal with 7 electrons in its outer shell, and it needs one more electron to complete its outer shell and achieve a stable electron configuration, similar to the nearest noble gas. Chlorine gains the electron lost by sodium, becoming a negatively charged ion. The sodium ion, which is positively charged, and the chloride ion, which is negatively charged, are strongly attracted to each other due to their opposite charges. This forms the ionic bond, creating sodium chloride or table salt. We also have ionic bonds in magnesium chloride or MgCl2 and calcium fluoride or CaF2. Now let's compare these two bonds together. In ionic bond, electrons are transferred from one atom to another, while in covalent bond, electrons are shared between atoms. In ionic bonds, it's between metals and nonmetals. One gives electron, the other gains electron, but covalent bond is between nonmetals and which they share electrons. Ionic bonds are often solid, forming crystalline structures, but covalent bonds are usually gases or liquid at room temperature. We say usually, guys, okay? Usually and often. Ionic bonds conduct electricity when dissolved or in molten form, but covalent bonds do not conduct electricity in any state. Lastly, we're going to talk about metallic bond. It is a type of bond that occurs between atoms of metals, hence the name. What a joke. Metallic bonds are present in sample of pure elemental metals such as copper and gold. Now let's compare the relative strength of intermolecular forces. Metallic bond is the strongest. Then we have ionic bond. Then we have polar covalent bond, which is between partially charged cation to partially charged anion. That is why it's like weaker compared to ionic bond, because ionic bond is between cations to anions, okay? And the weakest is nonpolar covalent bond. It's between nuclei to shared electrons. Now you might also want to know about single, double, and triple bonds. I give you the explanation on what they are, and you give me an example of each in the comment section. Now, a single bond, well, first of all, we can find them in covalent bonds. A single bond is a covalent bond when two electrons, so one pair of electrons, are shared. It's weaker than the double bonds. We have it in HCl. Double bonds are when two atoms share two pair of electron shared. It's a strong bond. We have it in carbon dioxide or CO2. And triple bond, can you tell me what it is? Good job. Three pairs of electrons that are shared between two atoms in a molecule. It is the least stable out of three types. Now, give me an example for a triple bond in the comment section. Okay, guys, that was it for today's video. And in the next video, we're going to talk about secondary bonds. If you have any questions, let me know in the comment section, or if you have any recommendations for topics. And don't forget to subscribe for more videos. And if this video helped you even a little, don't forget to hit the like button. And as I always say, stay curious, keep learning, and I'll see you in the next video.